Hi, let's get started with today's lecture. 10th week BIM and geometric modeling. Actually, the term geometric modeling with BIM, it sounds actually a little bit awkward because BIM already has information modeling, something beyond the geometric modeling. But I told you before, in reality, in your daily life reality, you are chased by some studio assignments and you got a lot of assignments for submitting some visualization outputs, project spinal, graduation exhibition, or some kind of some design work anyway. So basically design works all going to be somewhat in some forms visualized. So that is why I told you in reality some from user level visualization and representation, design representation always matters. That's why we are going to deal with this one. Okay, let's take a look. Actually, before getting started with some geometric modeling things, I'm gonna bring your attention again using this parametric modeling again because we have walked through some parametric modeling examples, specifically Dynamo BIM. It's a cutting edge. Actually, in Korean, this one, okay. The cutting edge technology in BIM and parametric modeling, one of applications in that area is Dynamo. Even if you are taking some fundamental examples of Dynamo, but now you have a really great power and resource to get walk through some even more advanced design approaches. I 100% sure. You know Dynamo. If you apply this one to your design project or some other things, output's going to be really great compared to your former some classical legacy based approach things. Of course it's going with BIM, specifically of course Revit. Anyway, the point is you already know what's the cutting edge design approach, but you are not pretty sure that okay, I know Dynamo, Family Editor, Revit, so what? How to use them? For answering the question in a simple way, I like to show you this one single example. Actually, this is a research paper published in 한국 실내 디자인 학회, right? Anyway, the student at the time working with me was just undergraduate students, which means someone like you. But she play with this Dynamo and find out some outcomes, very reasonable, acceptable, and very really good at the time result. And I think this is a really good example to show you how to use this kind of BIM or Dynamo apps in reality. So take a look. BIM-based parametric interior panel design approaches. So what is the interior panel? There are many panels, simple flat panels or some patterns, panels, whatever. But take a look. Very simple whole panel. We already looked how to create this one using Family Editor. You know how to make this. And you have some pavilion freeform surface and you make some grid and you can apply this one to this kind of assembly using this part. That's not totally new, you already know. But at the time, the role of Dynamo is here. Actually, in our lab exercise, you know how to control this assembly and you know how to control this part. But at the time, we used some kind of, they are very intelligent parametric, but we used very sort of handmade things because we draw this kind of 3 or 4 point contour vertex based line drawings, and we use some crate form using those 3 splines. So that's why I'm saying it's a kind of handmade. But what if we control these curve lines or this surface panel using Dynamo? And what if we can create a sort of patterns, something like this pattern, pattern 1, pattern 2, or some text, for example, Samsung logo or Apple's logo, something like that kind of bitmap images can be used for your pattern. So what's the source of drawing that pattern? Paints or some kind of pencils or some kind of drawing tools? Of course not. They are all these hole panels. You know, the small size hole, bigger size hole, they look different. They are, in other words, certain type of dot. You know what's dot? Dot is very important in printing and computer image making and so on. So let's take a look at this pattern. There is a pattern. It looks like this pattern. Okay, some wild horse, black and white stripe pattern. I'm not sure what it is. And take a look this one. Very freeform shaped, some curvy lines, and also this one exactly represented on the interior wall surface using hole panels. Of course, you can make this one by manual. I'm not sure the number of this one. What if this the height numbers for this one 10 and the width number for this one 50? In that case, simply total 500 panels. So you can recognize one by one from number 1 here until number 500 panels. You can manually control the whole panels like this, and then you can create any patterns by manual. But imagine that, how long it's gonna take, how long time you need for doing this, and in actual site, actual field, probably very, very tedious and laborious, so-called time consuming. It's ridiculous. Even if you design this one successfully using SketchUp or using any type of AutoCAD or any type of geometric modelers, design is okay, design is fine, anyhow you can finish it. But the problem is how to realize this one. In manual way, probably it takes really, really many days. Another problem is human errors. It's not easy to control the sequence of the construction, and it's not easy to resolve the final. It's not easy to guarantee final output's going to be something totally same to this one. I mean the design intent. But the role of Dynamo is here. Dynamo controls one piece by one piece of total 500 or even more panels. Controls entire panels like this way. So also Dynamo knows how many types, 4 types, 7 types, which means 7 different hole size, 4 different hole size. If we use more panel types, and then we can represent more sophisticated, more detailed output visualization. But the problem is more panels, more types, that's okay, but probably expensive. We need to order this panel to the manufacturer, the factory, to minimize size so that you can get them cheaper, very efficient way, probably faster, right? That is why Dynamo has a great role in this project. And take a look at this chart. This is an Excel spreadsheet. And what if we use the 4 types, and type 1, type 2, type 3, type 4 panels, total number 500. But take a look. This one single rectangle means one panel. So what if this one T2, T1, T3, T4, 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 T1, T1, something like that way, 500 times represented exactly same to this design. But you don't need to put those types or numbers by hand using Excel file. This Excel file can be created in automation. How? Thanks to Dynamo and Revit. So here is the Dynamo code, a snippet of the example of Dynamo code. But this project shows you how this kind of Dynamo-based, Revit-based design approach for parametric interior panel. The result is also very good. Take a look. If you don't want make this kind of patterns or this kind of drawings or some typos, I mean the text using this kind of whole panels, if you don't need, no problem. Just install them with the same size, same pattern, or a very simple pattern, such as this kind of line panel or this kind of line panel. That's fine. But what if you need some sophisticated design patterns, or some kind of your CI? CI means company identity. That's why I said Samsung logo or Samsung text, something like that. They can be exactly same design can be represented. What if this is the main building lobbies back wall? It's supposed to be looking very identical and something representing company's identity. In other words, design is supposed to be looking very unique. Anyway, for that purposes, design demands we need to apply that to this kind of design, and the solution technique can be resolved by using BIM, Revit, and Dynamo. Also, this one really useful for actual construction like this, and then you can get a lot of benefits from using this approach. That is why I'm saying BIM and parametric modeling example. By using this example, this case study, now you can easily understand how this one can be used on-site actual design projects. Okay, so that's why I brought to you to show you as an example. Next example is actually a video. Let's take a look this video. This is your senior students' final project. Final project a couple of years ago. Take a look. As you see, it's a sort of hotel project. They use this Google Plus to zooming in to their project site. Very visually impactful, right? And elevation stacked. So high-rise, mid-rise building, lobby from the mess, creating something like this. It's kind of sort of very small size building. For representing this one, they used both Revit and 3D Max right now. This thing. So visualization using Revit also possible, but for saving time or some other reasons, they also use the 3D Max as well. also imported geometry to Revit, and this is Revit generate section floor plan, and Revit's view, and some renders using 3D Max as well. The actual reason for showing you this one is here. They used facade design like this. Very freeform, unique design shape. They use family editor. In other words, parametric modeling. Take a look. This triangular shape is moving based upon their numbers. You see. Let me go back a little bit. Go back. Take a look. This triangular shape here is movable. So, in a certain parameter numbers, a little bit shrinking size, narrow, but probably it's going to be extruded like this way. So some different height, and this one, and this very narrow shape. I'm not talking about the effect or some visual, some aesthetic aspects of design. I'm talking about this kind of control can be made by actual parameters in family editor. That's my point here. Okay, what if this one made by some manual ways? This building facade system looking very unique. What if you try to make this one in SketchUp or AutoCAD, Rhino, something non-parametric based approach? Modification, updates, or some kind of redraw. What if you change the mass of shape of the building or size of the building floor? It's going to be somewhat disaster because you have to change entire geometry set according to your design updates, design changes. In reality, how about clients' demand? Clients, you know that clients wanna change day by day, every day. Designer side, that's really headache. But we're supposed to make it realized according to clients' demands. That's sort of design communication, something beyond our scope. But anyway, design changes are very, very common, inevitable. Okay. If that is the reality, how to resolve that situation, how to manage your situation much better. Parametric modeling, BIM-based approach, this kind of thing, going to be one of good answers. That's the point, okay? So this is one good example of this kind of parametric modeling, and that is why I showed you this example. Okay? Very nicely represented project. Okay, let's move to geometric modeling thing. Actually, last time I showed you this process. This is 3D Max using scenario for interior architecture and design projects. Defining UOD means universe of discourse. Do you remember that? Anyway, something in your mind is supposed to be listed up and structurized, and then so that you can make some real things. Even if it's a computer files, computer things, virtual things, much physical compared to something in your brain, correct? Anyway, defining UOD, very important. And retouching, final visualization, also very critical. Simply say, Photoshop skills gonna determine your final quality of your output. Anyway, two major parts, modeling and rendering. In other words, visualization. In a nutshell, two major parts. Actually, I recommended you to model using Revit-based modeling. What happened? Okay, anyway, Revit-based modeling and some other tools like Mentoray in 3D Max or even Rhino SketchUp, fine. Anyway, this is so-called interoperable. Of course, you can make something in 3D Max or SketchUp, everything. Every geometric model can be made by your own geometric tool, your preferred geometric tool, no problem. But now you know Revit and parametric modeling Dynamo Family Editor. This gonna save your life, save your time, save your money. I 100% sure. Even though you are only working with some design studio work or graduation work, whatever, anyway, in that cases, this one helps. So that means you don't need to know anything about some geometry things in 3D Max. No, of course at least you have to control, modify, update only by using 3D Max as well. 3D Max is very similar to SketchUp Rhino, but one difference is only in user interface. As you know, 3D Max interface, very scary, very messy, not good. SketchUp, really intuitive and easy to use and easy looking interface. That's why SketchUp is very popular. But their behind technology always same. They are all surface-based 3D based, okay? So just UI different. Also Rhino, even if it has some kind of NURBS surface based, very curvy, very natural, very powerful freeform shape generator. Anyway, their core engine almost same, okay, surface based 3D. But UI's user interface totally different. So you are spending a lot of time for learning that UIs, but anyway, my recommendation is at least you need to know fundamental UIs in each tool. You need to know SketchUp UI, 3D Max UI, Rhino UI, or any other tools UI by simple search or YouTube, whatever. You need to understand behind the technologies and then you need to reuse them using totally different user interfaces. Anyway, back to the topic. For your productive life, in our major, in our design work, you need to interoperable task. Actually, this is not real interoperability. You already know that. Semantic interoperability? No, actually it's not. This is kind of elementary level interoperability. But that's enough sometimes. Modeling Revit, rendering or visualization in Mentoray 3D Max, sometimes you need to visualize in Revit. Of course, that's okay, that's good. My point is, if you take maximum advantages from using only Revit, only 3D Max, only SketchUp, that's fine. But my recommendation always interoperability. You have to take maximum advantages from each tool's powerful features. So some given lab exercises and projects, I prove that kind of approach is better. Okay, that's what we have done so far. So this simple visualization I showed you last time, originally made by Revit model and 3D Max. In 3D Max geometry, I convert this geometry into editable poly. Because the reason I converted entire geometry to editable poly is I selected entire polygon and assigned Arcane design material. Totally same material to everything. And I changed the colors, some bright, light gray, close to white color. And then just adjust some exposure control and some environment setups in 3D Max. Of course, I need to install lightings like this. You see the lights are here, invisible lights, somewhere here, somewhere here, somewhere here, okay? Anyway, thanks to that lights, photometric lights, this kind of, because it looks coarse because it's kind of lower resolution render output. Anyway, very conceptually effective visualization can be created thanks to those two different tools, okay? Let me show you other case, other example done by students, okay? This one shows you Revit-based visualization. It's looking coarse because lower resolution render for saving time and black and white, and render output not that photorealistic because Revit-based render. But some renders, this is the faster process, making everything in Revit. Stop. Take a look. On the structure, how to find, okay, take a look. This is, sorry for lower resolution, it's not that visible, but anyway, in Revit's family property, you can assign Autodesk material. These are Autodesk material. So where are these materials? You can find out. Exactly same in 3D Max mental race Autodesk material. Okay. The same company, Autodesk Revit, Autodesk 3D Max, Autodesk AutoCAD. Thanks to same company, they manage this kind of texture material in same library. So Revit's surface render material and 3D Max surface render material texture, they all shared, which means if you model in Revit and export this one into 3D Max, and then you can reuse them. But if you use DWG file or other type of 3D file, those textures are going to be missing. They are gone. That's the problem. That is why I'm saying use FBX file. If you use FBX file, you can keep this material. Sometimes some problems, some errors happened, but anyway, usually, thanks to FBX feature, you can reuse Revit's default or some your customized material can be alive in 3D Max. That's what I'm saying. But actually this example, this case, this is only Revit-based visualization. Let's take a look. Revit's light control, Revit's sun setting, and Revit's material control. Take a look this render scene. This render scene is not made by Mental Ray 3D Max. Take a look, lights, light bulb. This is real wall attached light object, and it has real light source, and external sun setting also makes this kind of shadow casting and external view very bright because this is kind of daylight scene. But thanks to Autodesk material for flooring and some selective wall patterns, red color, and this couch is red color, this one looks very colorful and very visualized, very effective visualization output. But remember, this is not AutoCAD. This is Revit's render. The problem is slow. Another daylight scene render. This is original render file. Even in original render scene, if this is looking something like this, if you Photoshop this one can be really visually effective visualization output. photorealistic render, another one. Again, this one generated by Revit only, no SketchUp 3D Max Mentalray used. Also in Revit there is cloud render. You don't need to use your CPUs or GPUs. Cloud render means Autodesk Cloud Server going to render your scene using their resource, their CPU, their memories, and you can get email attached by this render output. So try it, okay? Cloud render in Revit for saving your time. And anyway, the point of my this case's point, my short conclusion is, even if you are going to use Revit only, no problem, okay? But if you want to use only SketchUp or only 3D Max, that's not good, at least in this class. In my general perspective, that's totally fine. But this is sort of BIM oriented, BIM weighted class, this Digital Design Studio at this semester. That's why we are opening this class with Revit and BIM approaches. So I recommend you to use Revit and 3D Max or even any other tools, interoperable design representation work. That's totally fine. Next option could be Revit only. Okay, something like this good Revit-based visualization example. Okay, this one doesn't have any retouch, any post-process. Post-process simply means Photoshop, retouch, or some decorative things for making your final render outputs much better. This one doesn't have any post-process, which means this looks very nice even without post-process. If so, if you Photoshop this final output, this one going to be much better and much enhanced. I pretty sure that. Okay, let's take a look another example. This is Samsung Hall remodel virtual project using Revit. Take a look. This one also Revit-based representation. Making Samsung Hall's annex building. Let's take a look. Even if you don't like this kind of black and white scene, anyway, you know this building over there, that's Samsung Hall, and this is the annex building part. Annex in Korean, that's something like this, okay, in Korean. Anyway, designing new annex in this, actually there used to be Chesun Hall was here, but they removed this one and created a new one for students, this deck structure and this column structure as well. Anyway, the point here is this is black and white representation, but looking very architectural. Why? The purpose of this visualization is not showing you the exterior material or photorealistic render or something spatial. Spatial here means this one, okay? Spatial effect using this visualization. That was the intent for showing you this wide angle view. Very useful for this kind of architectural representation. Okay, I'm sorry, let's keep seeing this one. Okay, resume this scene, take a look. shadow casting changed because of the sun's moving, right? And night scene. How about this night scene? Also, this one doesn't have any retouch, but this one emphasizes somewhere this place or some other exterior places looking something different. All are dark except this place. That means this place can be accented, emphasized. That's probably the visualization intent of this one, designers. And section views, even without dark shadow casting, this one looks okay. And walkthrough video created by Revit. For saving time, only ambient shadow and some consistent colors. No photorealistic, but take a look. Very spatial, very spacious. New space just created. And this is over the deck area. Visualization, representation, only done by Revit. And also, take a look. Revit's render. This is Revit's render style. Something coarse and not that looking fancy, but that's okay. Because of the limited time frame, this kind of visualization looking not that professional or looking coarse, but totally fine. Sometimes this kind of, what is this kind of thing? Line stroke visualization. Even though interior design is supposed to be something photorealistic, in other words, very colorful, but even to interior design, especially for this kind of exterior design, line stroke visualization sometimes very effective. You know, I believe you know what I'm saying, the intent of this one. Sometimes it's really, really effective and very useful. So, if you fail to create a very photorealistic or something great, something stunning visualization, only hidden line based representation with some ambient shadow, or just a simple shadow casting, sometimes very effective and sometimes very, very enough, because we are usually dealing with schematic design, not final design or very detailed design for construction documentation or something, usually. So if our focus was on some schematic design, in other words, schematic design is early or concept design. So concept design representation sometimes enough by using line stroke visualization, hidden line visualization, something like this. Instead, you have to make very good angle. That's very critical. If so, this kind of visualization enough. That's my point. Okay. Go back to scene. Take a look. Sometimes this kind of photorealistic render, this one looking not that photorealistic. That's kind of limitation of the Revit or 3D Max. But you can also use Lumion. It's a commercial tool, but by using students' demo version, you can make this kind of scene, originally created by Revit, can be visualized even in animation, very, very realistic. There are many external tools available you can use. Okay. So now we have walked through this kind of visualization. That's sort of very selective representation and talks about BIM and geometric modeling. In the series of lab exercises, hopefully you can get some more opportunities and possibilities for your further design development. Okay, thank you.